So imagine this, you walk into a hospital on Monday with a failing heart, and by Friday the doctors have handed you a new one. It's not borrowed, it's not donated, it's grown, it's fresh, it's yours. This sounds like science fiction, doesn't it? But actually in 2025 it's beginning to sound more like a business plan. So imagine every organ in your body begins as a cluster of stem cells. These are basically tiny biological blank pages. So if you give them the right instructions, they can turn into anything: bone, liver, or lungs. They're like Lego bricks that build themselves. There's no manual required. So the challenge here isn't making cells, it's actually persuading them to cooperate. If you think about your heart, it's not just a muscle, it's rhythm, it's structure, and it's timing. So like an orchestra that refuses to play unless every instrument knows its cue. So to solve that, scientists have borrowed from printers. We now have 3D bioprinters that lay down living cells layer by layer, a bit like colourful ink. Each drop lands on a scaffold. It's a soft frame that shapes the growing tissue. This is basically medicine's answer to build your own heart kits. Flat pack biology, courtesy of science. More recently, labs have grown mini livers. These are functional, and they've grown them in less than a week. That's roughly the time it takes to binge watch your favourite show on Netflix. And these livers, they even filter toxins, they produce proteins, they regenerate when they're damaged. They're tiny, but they're very much alive. So when we step inside a tissue lab, you're going to see something surreal. You've got rows of clear bioreactors, and they're each humming softly. Inside each of these, you've got billions of cells that swim in nutrient-rich liquid. Oxygen and glucose is fed to them as they slowly knit themselves into tissue. It's the closest thing that humanity has to a life factory. So, picture a hospital where you can order organs like pastries. It's a bit like Costa, really. So you've got 2 kidneys and a new cornea, please. And imagine the technicians behind the glass carefully assembling them. It's baking, so to speak. This is the future of medicine. And a week later, your name is called. Your new heart is ready. It's still warm. Right now, over 100,000 people in the world are waiting for transplants. Many die before a match is found. So growing organs is not about luxury, it's about survival. The race isn't against disease anymore, it's against time. The body, though, it prefers patience. If we think about our real organs, they grow over months and they're guided by millions of chemical whispers. If we rush it and then chaos follows, cells grow in the wrong places or they stop listening. If you think about baking bread in a microwave, the outside, it looks fine, but the inside, it's a disaster. So, how about we speed things up without breaking biology? There's 2 words, scaffolds and signals. Scaffolds, these give shape. We think of them as the organ's skeleton. Signals, these are the chemical growth factors. They tell cells when to divide and when to rest. Put these 2 together and they turn cellular chaos into a choreographed dance. And then we've got this really uneasy question. If we can grow a heart, could we grow a whole person? Researchers are really careful to draw the line. No consciousness, no brains, only organs needed to save lives. But still, the thought lingers. What if someone doesn't stop there? So let's fast forward 20 years. You're 75 and your heart is a bit worn. Doctors take a skin cell, they reprogram it, and in 1 week, voila, your new heart. There's no rejection, no waiting. It's your DNA inside and out. It's a bit like replacing an old battery, except the device is you. Isn't that remarkable? And let's be honest, it's slightly terrifying. At the moment, we're perfecting organoids. These are tiny versions of real organs, grown in dishes. What these are used for is helping to test drugs safely and to study disease. A full-sized human organ remains the final boss of biology. But every single month, the gap is narrowing. But naturally, industries are circling. We've got startups promising printable hearts within a decade. And then you've got your pharma giants that are in trillion-dollar markets. Medicine could shift from fixing organs to manufacturing them. You know, that's splendid, unless you're an insurance company. With all this being said, fast-grown tissue, it can misbehave. Some cells can mutate, others stop responding. And if we've got too many growth signals, well, you can risk cancer. Too few, and the organ collapses into mush. It's really delicate. It's a bit like balancing a souffle on a seesaw. Let's talk about my own experience for a second. I mean, I've tried growing a few things. I tried growing basil in my kitchen window. It withered and died within days. But somewhere out there, you've got a team of scientists growing human hearts that beat in glass chambers. It's humbling, really. We can't keep a houseplant alive, but we're tinkering with life itself. But to be fair, nature's been doing this for ages. Axolotls can regrow limbs, starfish, they can regrow bodies. Even us humans, we can regrow parts of our liver. All we've really done is peek at the recipe and start scribbling notes. But if your organs are replaced one by one, your heart, your lungs, your liver, at what point do you stop being you? Philosophers call it the ship of Theseus problem. Science, for now, politely ignores it. I mean, this is very British, isn't it? By 2035, scientists expect the first fully transplantable 3D printed organs. Livers first, kidneys next, hearts will be soon after. For the first time, humanity could erase the donor waiting list. It could be medicine's moon landing. And maybe one day, hospitals will feel more like workshops of renewal. Not places of waiting, but places of restoration. When a body fails, we simply rebuild it. Death, for some, it might become negotiable. So what if we really could grow entire organs in a week? We'd save millions of lives, yes. But we'd also change how we see ourselves. We wouldn't just be living things. We'd be editable, upgradable, replaceable. Immortal in increments. Maybe the miracle isn't copying nature, but finally listening to her. We're not fighting life now, we're learning its language. If this made you think, tap like, and remember, what happens if we never stop thinking? This is Thinkverse.